Let's now learn about some more mathematical operations and also about rounding numbers. And we have already been using lots of mathematical operations. For example, plus, minus, times, divided, exponentiation, and so on. And so we don't need to go over these again. So let's start here with the square root. And so just like many other functions, the square root is part of the math namespace. So math.sqrt. So this stands for square root. And so all we need to do is to pass in the number, and then it will give us the square root. And the same could be achieved using the exponentiation operator as well, by doing 1 divided by 2. And so that 2 is the square. So we want the square root, so we use 1 divided by 2. And actually we have to put this into parentheses, and now it works. All right, and the same would work for a cubic root, for example, of 8, which would be 2. And so actually this is, I think, the only way you could calculate a cubic root if you need it. Next up, let's get the maximum value of a couple of values, okay? So again, we use math and .max this time. So let's just use a couple of numbers here. And so, as the name says, the maximum value gets returned to us. And this max function here actually does type coercion. So it should now still give us 23, okay? However, it does not parsing. So if we try 23 pixels, for example, it will then result in not a number. So this does not work. All right. And just as we have max, we also have min. Let's just put it back to 23. And now here we get 2. All right. Now, besides a couple of methods, there are also constants on the math object or on the math namespace. And so, for example, if we wanted to calculate the radius of a circle with 10 pixels, we could do that. So for that, we use math.pi. And for now, let's just take a look at that. And so it is this constant that you might know, probably. And so again, let's say that we get like 10 pixels from the user interface. So we can say parse float of 10 pixels. And then we simply have to square this value. This is how we calculate the area of a circle with this radius. All right. Now, another thing that is on the math object is the random function that we already have been using a couple of times. And it's very important to be able to generate good random numbers when we need them. So before, we have already created random dice rolls, remember? So that we did by math.random. And so this will give us a number between 0 and 1. So as I reload, you see I get different values. Then we multiplied this by 6. And then we removed basically the decimal part by doing math.trunc like this. Okay. Now the problem with this was that then the highest number could be 5. And so we simply added +1 to offset that truncation here. So that cutting off of the decimal part. And so now we're going to get values here between really 1 and 6. But now let's actually generalize this formula so that we can use it from now on to always generate random integers between two values. So let's create random int. And we want to pass in a minimum and a maximum. And then we want to return that number. So as always, we need to start by removing any decimal parts of the result of math math.random. And then we will multiply this math.random by max minus min, okay? And then we add that 1 back on. And so let me show you why we do this. So it is because it gives us a number between 0 and 1. So math.random is between 0 and 1, right? So if we multiply this by max minus min, then we get a number between 0 and max minus min. Okay, and now if we add min to all of this, so the minimum value, then we get min to max minus min plus min. So we added min on both sides here, basically of the equation. And so then we can cancel this minus min plus min, and we end up with a range between the minimum and the maximum value that we specified. All right, so let's just add that here as well. So adding that minimum that I just explained here in this last step. And so this is how we end up with a nice function which will give us always a number that's going to stay between min and max. So let's try that out. So random int, let's say between 10 and 20. And so here we see 20, and let's try it a couple of times. So I'm going to save this file here a couple of times. And you see that all of these results are always within this range. Now I maybe overdid it. Probably it's easier to just reload this page. All right, so we haven't seen any 10 or any 11 yet, but it's going to work just fine. And we will get it if we reload it even more times. Okay, next up, let's talk a little bit about rounding. And let's start by rounding integers. So you can add some comments to this here if you want, but I'm just going to leave it like this. I will just add here rounding integers. And so we have already been using math.trunc, right? So what this does is to simply remove any decimal part. And so we end up with 23 here, right? Let's just take this one out. All right. So again, this one simply removes any decimal part always. But we have also other ways. So we also have round. So math.round. And so this one will always round to the nearest integer. So this one is going to be 23 and the other one 24. Let's duplicate this a couple of times to save us some time. Then we also have ceil. And this one will basically round down. So both of these results should become 24. And so that's these two here. So line 318 and 20. Or actually, it's these two. So I'm confusing these numbers. All right. So both of these are 24 because they will both always be rounded up. And then we also have a floor. And so these two will both be rounded down to 23. And so that's what we get here. And by the way, all of these methods, they also do type coercion. So if we do this, then it's going to work just the same. Now you might think that floor and trunc are very similar. Let me just put this one down here. And indeed, they do the same when we are dealing with positive numbers. So basically, floor and trunc both cut off the decimal part when we are dealing with positive numbers. However, for negative numbers, it doesn't work this way. So let me compare them here. So trunc minus this and also floor. Okay, and so now this one here, just like before, gets truncated. So it simply removes this part, but floor now gets rounded to minus 24. because with negative numbers, rounding works the other way around. And so actually, floor is a little bit better than trunk, because it works in all situations, no matter if we're dealing with positive or negative numbers. And so here, let's go ahead and replace this with floor. So we're looking for a really generalized function here. So this random int function should work in all situations, even if we give it negative inputs here. And so therefore, we need to work with floor here. All right. So that's rounding integers. Let's talk about floating point numbers. Or we can also say decimals. And now with decimals, it works in a little bit different way. So let me show you how. So in decimals, we have to specify the number like this in parentheses. And then on that number, we call the toFixed method. Okay, and let's try it here with 0 first, just so we can see the result. And so you see that with 0, it is converted to 3. But this 3 is white here, while these other ones are pink or purple. And so this means that is actually a string, right? So toFixed will always return a string and not a number. And that's important to keep in mind. So if we set here instead of 0, the 3, then it returns 2.7 and it adds zeros until it has exactly 3 decimal parts, just like we specified here. All right. Now let's add something more here, like 2, 3, 4, 5. And let's say we only want 2 decimal places here now. So this should become 2.35. And indeed it does. Okay. And if we now wanted to convert this result to a number, then we simply would have to add the plus sign here. And then we already know that this here converts a string to a number. And indeed, now it is purple again. So with decimals, it works differently than with integers. And that's once again because things in JavaScript evolved kind of in a weird way in this kind of old language. And if the language was designed today, definitely this would be very different. But yeah, this is what we have to work with right now. Okay? Just keep in mind that this here works in a similar way than the string methods. So this is a number, so it's a primitive, right? And primitives actually don't have methods. And so behind the scenes, JavaScript will do boxing. And boxing is to basically transform this to a number object, then call the method on that object, and then once the operation is finished, it will convert it back to a primitive. Okay? All right. So once again, this lecture looked a little bit like a reference of a couple of different methods. But to make it a bit more fun, let's now apply some of this to our Bankist project. And the first thing that I want to do is to round the requested loan amount. So this one here. So this looks weird. Oh, it's because of this number. Okay. So we could use this application in this other page here on the other side, but I prefer to have everything here in one screen. But anyway, I can take a loan like this, right? With the decimal part. But in practice, I've never seen a bank giving out a loan like this. And so let's apply the rounding to the loan functionality. So that's here. And the rounding then needs to happen right here. So the value that we get from the loan here needs to be rounded down. Okay? And then we actually do not need to convert it to a number because, as I showed you before, the math.floor method actually does type coercion itself. Okay? And we are using floor here because we simply want to round any value down. All right? So in this case, it would have been 150 and that's it. So let's try that again now. So let's ask for 150.56. And so now we get just this. Okay, probably I added one more zero there, but that doesn't matter. Next up, let's use the toFixed function or method to make our numbers here look a little bit nicer. So here, for example, we have this decimal part with the two numbers, but here then we only have the 0.9. And so this should be like 0.90. And here it should be 1300.00. And the same also up here. All right. So for that, we can use the toFixed function that we just learned about. And so let's do that in all the places where we display numbers on the screen. And so that's in these three functions. So display movements, display balance, and display summary. So let's start here at the top. And so here we have the first occurrence. So this movement here is a value, so it's a number that we display. And so on here, we can simply call, so .toFixed, and then with two decimal parts. All right. And now let's just copy this from here. So display balance. So let's do the same here. And the same in the summary. And so that will then hopefully also fix this weird, really long number that happens because of the rounding errors in JavaScript that I just explained to you in the previous lecture. So everywhere we print a number, I will do this now. So, okay. Then also on this result and also on the interest. Let's give it a save. And that's a lot better. So it worked. You see, now we get 0.00. And here we also get nicely 0.90. And the same down here. We are now back to having just two decimal places, just as we requested, so to say. So this lecture was kind of a short overview of some more math functions, including some rounding and also some other stuff like getting the max and the min value. And yeah, so good to know functions. And of course, there are a lot more. So if you need something like logarithmical functions or sinuses, then of course you can always check out the MDN documentation.